hopefully there's going to be people monitoring the chat on YouTube anyway. So, good evening everyone. We are live from Microsoft Reactor again in London, and this is such an awesome venue. Just thanks again to Microsoft Reactor and Rad for hosting us this time. So this evening we've got 2, maybe 3 talks lined up. Just trying to pick out one person from the crowd who might be talking. So we might have a little data visualization treat towards the end. We've got 2 scheduled talks coming up. First up, we've got Giorgio Boa, and he'll be talking to us about what are you going to talk about? Micro front end. I forgot the title of the talk already. It's actually on the slides, so if I bothered to, if I actually went over to my slides here and went over to the next slides, we could look to that. This doesn't relate to anyone on the stream watching, but thanks for tuning in anyway. We've got some general housekeeping we need to take care of before we start. As a community event, the Svelte Society has a code of conduct which everyone should be adhering to. You can check that out over on the GitHub Svelte.js community URL here. There's also one for Microsoft Reactor where we are at the moment as well. So if there are any issues for any event, please either get in touch with one of the community organisers, myself, Akash, or one of the staff members here. Okay. I don't know what to do about that. Can anyone hear? Okay, here. Okay, I'll try a different microphone. So thanks on the stream, everyone, for that. How is it now? Okay. I'm going to hope that's okay. I'm going to sort of put this to my face. Georgia's up in soon, so I'm going to have to pass this over. I'm hoping. No. Still static. Sounds like. Right. Okay. 1 minute. Okay, so thanks everyone on YouTube. I'm hoping that the sound is better now. I've got to find a way to share my screen again. Here we go. Okay, can you share that? Hey, okay. Audio better? Sweet. Okay, so maybe it's just my loud voice making it worse. Okay, awesome. So everyone on stream, I hope you're happy now. We've got that sorted. Anyway, um, uh, again, this is for the people here. Safety information. I'm just going to rattle through this quickly. Then we'll get on with the talks. So we have the emergency information we need to take care of here. So if there is a fire alarm, you need to take note of all this information really quickly. So if you've got your phone on you, take a picture now. Usual sort of fire evacuation stuff, follow where everyone else is going. The muster point is just outside here. So if you come out the building here, turn right, that's where the muster point is. First aid instance, we've got Esther, who is over the back there. Anything which happens, go and report it to her and she'd be happy to help out. No smoking. I mean, it goes without saying, really, but no smoking. Okay, Microsoft Reactor. Thank you again. I'm going to do the pun, which I did in December. Not Reactor, it's Svelte. Anyway, moving on. So the schedule. Sorry. We've got Giorgio Boa from Clarinet, who's flown all the way in from Italy to speak with us tonight. So thank you very much, Clarinet, for sponsoring Giorgio come out and talk to us. And then we're going to have one of the organisers of the London Meetup, Akash, come and talk to us about the client server barrier using TypeScript. So first up, we're going to get Giorgio up here. So I'm going to slide off this way. I think Giorgio's mic'd up already. So it's going to add Giorgio to the stream. And then everyone here can start enjoying that. Okay.
This one?
The camera seems fine.
Yeah, test, test.
Yeah. Hang on.
Test, test. Is it working?
Let's go back to YouTube, find out.
Yeah, yeah, no problem.
Oh, yeah, okay, it's good.
It's good?
Yeah, thank you.
Yeah. I can speak really fast, so I can say the same thing. So welcome everybody. Micro frontends with Svelte and Module Federation. So let's start from micro frontends. With micro frontends, we have the same idea that we have in the microservices. From the monolith, we can split into many microservices, and then we can move this idea to the front end to have vertical subdomain. And one vertical subdomain is a subdomain of an application. So what is a subdomain? Here we are describing a flow of the application, and the event storming workshop help us to do it. We can see that here we have the blue subdomain. This is the core subdomain, so the most important part of our application. So in an e-commerce application is sell something. We have a supporting subdomain, the orange one, and then we have the generic subdomain like authentication, payment, so on and so forth. So with these subdomains in mind, we can split our application in many parts, our front ends in many parts. But do I need it? Do I need to split my front end in many parts? These are few company that is using micro frontends, and as you can see, all these company are big company with complex application. We can use this architecture to use the strangler pattern. So the same application, we can use this strangler pattern to renovate our legacy application. So imagine you have an old Angular.js application. We want to renovate it, update some parts with Svelte, of course. So we can use this pattern to piece by piece renovate it. So imagine we are updating, we are refreshing an house. We have to take off all the doors, and then we can put it again. So this can be a subdomain. Another subdomain for a house can be a window. Another subdomain could be the floor. So piece by piece, we are renovate our house, and in our work, we can renovate an application. So we can use it, this architecture, even if we are a startup and not a big company with a big complex application. So the core ideas behind micro frontends. So model around subdomains, as we mentioned before. And then we have parallel development. So if we have multiple teams, we can develop in parallel, of course. And then we can have independent deploy. So every application can be independent for the deployment part. And then we can have independent technology. So in this case, in the case of a legacy application, we can have the Angular.js one with micro frontends in Svelte, but we can have also another micro frontends in Vue or React. So Svelte is better, but we can use also other technology. So the cool things about this approach, we are reducing the scope of our application because we have less code to maintain. And also we can have autonomous team, because if we define the subdomains, we have an autonomous team because there are less over communication from the teams, because is really bounded context. Then we have a business unit isolation, of course. And we can innovate. So we have a less scope, less code to maintain. So we can update the libraries, we can try new things, and then we can share also with the other teams the cool things that we knew. What are the extra efforts of this approach? There is a DX improvement. So we have to, for the test, all the application, we needed to struggle a little bit because we need to load the different front end from different part. So it's a little bit, it's an extra effort, I mean. We need to guarantee UI and UX integrity because for the end user, the application is one, but in reality is a lot of application that is combine a new one. So the UI and the UX is something that we need to put an extra effort in it to be really the same application. And we need to put an extra effort on the testing part because we know our application, but if we need to communicate with the other application, we need to test, and it is more difficult to test also the other part, contact the other team, and stuff like that. And then we have another pain that is the performance, because if we are loading Vue, React, Svelte, maybe the old Angular.js application, we need to ship a lot of JavaScript to the browser, so the performance can be worse. Okay, but how we can do it? How we can slice the monolith? We can do the vertical split. So basically, every route, we can create a micro front end for every route. So this is one is the home page, and the blue team is the owner of this home page. And we have the checkout flow, and the team green is the owner of this part. Of course, in the checkout, we can have multiple routes, and the green team is the owner of all this route. So it's not one route, one team. Because in the checkout, we can have multiple routes for the whole process. And we can have a little bit difficult splitting, the horizontal split. So here we have a beautiful dashboard, and the blue team is the owner of the header and the menu. We have the green team that is owner of the dashboard, and we have another team, the red team, that is owner of the last part at the bottom. So as you can imagine, this kind of approach is a little bit difficult to achieve because you have multiple micro frontends in the same page, so you need to communicate in the right way from one micro frontend to another. So my advice is to start with vertical split, and then if you need, go for the horizontal split with a spike or something like this to understand what are the pain of your flow and your application. We can have multiple compositions. So we need to compose this application to ship it to the browser. And we can compose this architecture in three ways. We can compose it on the server. So the server loads all the micro frontends and then ship the final HTML to the browser. We can compose it in the edge side, so in the CDN or in the Lambda. So the Lambda loads all the micro frontends and then ship into the browser. And then we can have the client-side composition. In this session, we focus our talk into the client-side composition. We used to have a shell application, so a base application, and on top of this, we can load multiple micro frontends at runtime. We can use iframe, but it's not a good solution, let me say. We can use web component, and then we can use a runtime loader and single SPA, Luigi, and Webpack are few packages that allows us to load these micro frontends at runtime. Then we are focusing this session in Webpack part. And Webpack is based on import map. So we can use, instead of the JavaScript, we can use an import map that is a map that allows us to map a specific import to a specific library. So we can use this kind of code, and it's a normal code that we can use right now in the browser. We can console log the .js format, and it's working pretty fine. Here, the import map, I get a screenshot from can I use the import map. I cut off the Internet Explorer, you know, but it's quite common to use this import map in all the browser, so we can do it. So on top of this import map, a guy, Manfred Steyer, created this native federation package. So it's a set of basic API, and this is the layer here. And then on top of this layer, so on top of this basic API that are using import map we saw before, we can create our own plugin. And he created this Angular Architect native federation. And this one is my package I create for Vite. So now we can use module federation with the same APIs also in Vite. A few months ago was not possible to use it with Vite, but only with Webpack. And now I can show you how. Here, another square, so you can create your own, of course. But let's move on. So I read this tweet about Zach Jackson, that is a main guy that is following module federation stuff. You can follow him on Twitter, and he's tweeting a lot of things about module federation. And in August, 29 August 2022, he made module federation open source. I was in vacation and I saw his tweet, and I thought it's a difficult task for me. Let's jump into this challenge. I wrote him and in Twitter, and I wrote to Zach Jackson and also Manfred Steyer, the guy we saw before with the basic API. And then in September 2022, I released this Joboa, that is my nickname on GitHub, Vite module federation. Great. So now, finally, we can use the module federation also with Vite. So big round of applause. Thanks. So I created it in my personal repo. Then Zach contacted me and said me, well, you know, we can include it in the module federation organization. And then I archive my personal repo, and I move all the code in the module federation organization. I'm a maintainer of this repo, but you know, under this code there is a big organization, module federation, so I'm quite proud of it. So let's have a demo. Here I create a Svelte micro frontend Spotify. So it's a clone of Spotify. You can find this project in my personal GitHub. And it's a monorepo. We have a host, our app shell that is loading the micro frontends. We have a remote that is a Svelte application that is loaded from the shell, from the host. And here we have a bunch of configuration. So the host is a Svelte application with Tailwind, and the remote is another Svelte application as well. How we can configure all this application to be ready for the micro frontends architecture? We have a Vite configuration, and the remote and the host are quite similar about the configuration. So in this configuration, we need to import federation, and now I import it from my personal repo, but you can do it from the module federation 1, because now is the way to do it. And here at line 15, you can see that I'm calling this federation function. Basically, a Vite plugin is a function that we can personalize, and we can create our own logic. And in this federation function, we can pass options, and we pass the adapter. We need to pass the adapter because we need a Svelte plugin that I create it inside of the project. We need this plugin and for the adapter to adapt the Svelte code to the Vite, because Vite doesn't really know what is a .svelte file. So we need to translate it for him. So here, ES-build Svelte plugin, you can see there is a bunch of lines about the Svelte things. So we can basically translate the .svelte file to a readable file for the web server. So Svelte plugin arrive directly from ES-build Svelte plugin, the file we saw before. And then we have a special configuration, federation.config.common.js, and is here. So this file here is a configuration and is using native federation, the package of a layer of the API, basic API we saw about before, and is Manfred Steyer is the maintainer of these APIs. So we can pass a name for the remote, of course, is remote, and if we go into the host, is host. Okay, nothing too fancy. Okay, and then we can have expose. So we are saying this application, this Svelte application, is going to expose at this name, basically, is going to expose media player.svelte. That is a component, Svelte component. And here we can expose more than one component, of course. So if is a library, design library, we can expose multiple Svelte components. And then we have a shared configuration. So if we need to share something with the host and the remote, we can use this particular configuration. We can say, okay, we are using both Next.js, so maybe we can share this dependency, because if we load 2 times Next.js, maybe is not so good, or maybe there is a clash at runtime. So with this particular configuration, we are configure all the module to load only once. In this case, for the example, Next.js, or maybe it can be a different library, of course. And we can set some configuration. So if we have a singleton, single version of a shared module, and then we have a required version and stuff like that. All this configuration you can read from the website, of course, and is literally the same that we are using with Webpack. So you are able to load in a Webpack application, you can load a Vite module federation. So if application with Webpack is configured to load micro frontends, you can mix and match the two things, because the native federation API are the common way to do the things. So the configuration is really the same. Okay, so we can start our application. So if I run npm run dev, here I create in the root this package here. You can see that dev run the npm run all, and is running the dev mode for the host and dev mode for the remote. So if I run this, maybe this one, okay. As you can see, we are exposing two applications, one with 4,173 and 74. Okay, maybe we can do again. 73 and 74, great. So if I open the 73, that is the host, 73 is the host, 74 is the micro front end that we are loading. So if I refresh here the page, as you can see, we have a normal Spotify clone, but one of these components is the micro front end. And I want to guess what is the micro front end of this application. As you can see, here we can interact with the things. So any guess? Media player, yeah. Because we saw in the configuration that we are exposing the media player. Great. So if I kill here, kill all the process, and then I run dev host, simply the host, without any micro frontends. So dev host is always 73. As you can see, the media player is gone. And here we have a placeholder for the micro frontends. So this is another benefit of this kind of architecture, because if one micro frontend fails, the application is still running. And it is a big advantage. So we can run again the remote. This is working in dev mode and in preview mode as well. But another interesting thing is that if I build the host, or maybe it's better to build the remote. npm run build remote. Okay, here we have the dist folder, and as you can see here we have remote media player. This is not a normal way of bundling a Svelte application, and it's creating this remote media player, and also is creating this remote entry.json. And here we can have all the shared dependency, and we can have also the expose key value import map, let me say. This is basically an import map, because we are saying with this case, with this key, we can have this file. Okay, but I want to do a little bit more. So let's run again the dev mode. Dev. We are running the host and the remote. Let's jump again here. And I set a few breakpoints to show you how it's working under the hood. So maybe I can zoom a little bit here. Okay. Okay, great. Maybe like this is better. Okay, so if I refresh the page, we can import the Vite client, of course. We can go on with other files. Maybe this one here. Great. So we can go on. Here we are init the federation. So for create a module federation application, we need to also to call this init federation function with a specific configuration. And this configuration arrive from an external resources. So can be a CDN, can be a static file. So as we can see here, this is the configuration. So we are loading and we are init the configuration with this key value here. So we are doing remote is inside of the other web server, so 4174 with this specific file. So read me this file and get in your cache to be ready to load all the micro frontends. So in the network, we can see that it is going to load this configuration. If we move on, we can import. This is inside of the library, of course. The native federation, maybe it's too small, but it is the native federation. So it's going to import the map, mix and match all the things. We can move on. Is loading different things. And then in the Svelte host, here, in the Svelte host, in the app Svelte, at the line 9, I declare a remote app target. And here I simply call load remote module that is arriving from native federation. And I'm loading the module, the micro frontends. And from this module, I can instantiate a new Svelte application to render these micro frontends into the host. So let's move on here. If we go on inside of the libraries, we can see here is loading the bootstrap.typescript. But here you can see that is loading our Svelte. Let me say, this one is copy paste here to here. Maybe you can see that is loading the module, the media player.svelte. This is a JavaScript module. So it's going to load this module, and then we can finally render it at runtime. So this is the import map library. So my plugin is using native federation, and then native federation under the hood is using import map to load all the micro frontends, and then we can finally render it inside of the host. Great. So I can close it here. And as you can see here, from the micro frontends, we are able to move something inside of the host. We can communicate from the micro frontends. We can do it by custom events. So here in the remote, we have the media player.svelte, and here a bunch of HTML. But here, when I click on that particular icon, I can emit a next song event, and I dispatch this event in the window.dispatch event. In the other part, the host one is going to listen to this particular event. So on mount, we are doing event listener to this particular events, and then it's going to move the index of the songs. So as you can see, we are able to communicate through the micro frontends. Great. So that was the demo. Then we can move on. I'm Giorgio Boa, full stack developer for Clarinet. You can find me on Twitter and LinkedIn. My handle is Giorgio_Boa. And I used to reshare and post things about frontend. So if you like, you can follow me. And thank you.
Awesome. Thank you, Giorgio. So we've got Akash up next. Akash, everyone on stream, just bear with us while we get Akash set up. Yeah, you can pop it out.
And get this plugged in. I think this isn't connected to this yet.
Yeah, everyone can hear you.
Okay.
So share your screen.
Yeah. I just need to do that.
Change it to that one.
It just froze. Okay.
Right. Giorgio, the camera wasn't connected for the whole of your talk. You've got the screen, but it's not the camera. It was in the bottom corner. So sorry. I didn't want to tell you were very busy talking, so I didn't want to distract you.
Yeah, share the entire screen.
Yep. Right. So check.
Hello. Hello. Yep. Hello, indeed. Okay. All right. I'll start. So yeah. Hey everyone. Today I'm here to talk about TRPC or Rocket RPC. I know what you're thinking about. So yeah, today I'm here to talk about Rocket RPC. So I'm going to set the context for the talk first. The story starts in 2020. It's the peak of pandemic. Everything's shut down. Everyone's at home thinking about ideas, about apps they can sell when everything reopens and the pandemic ends. Me and a friend of mine, we are thinking we could build an app, a menu ordering app for restaurants to replace menus, so people can scan the menus via their phone and then get into the app and then order through that, so they don't need to do any human contact, no human connection. Hopefully good for after the pandemic. So we start working on this thing. Well, the first thing that we work on obviously is sort of the order screen. So let's try to break down what's actually happening here. On the front end, we have sort of like a list component going on here where, there's like a bunch of data we are getting from an array. And then whenever we are clicking on one of these individual components, we open up another component where we can allow our users to customize their order. Now, in terms of the front end, this is pretty easy to set up. Everyone knows how this works. This is like an array, like a list of strings or something, and then you click on it, and then you push the whole details to whatever the next component is. In terms of the backend, it starts to get a bit more complex, of course. So you have different tabs here. So each of those tabs needs to have a different API. You need to paginate these APIs. You need to return different data based on which context you are on at the moment. So let's say we were done with that. Next, we wanted users to use our app. So we had an authentication screen. We ask users to log in, and login screens can get pretty complex. We don't know what we need from the user at any point. We might need the phone number one day, their address the other day. And this also keeps on changing, which keeps on adding to the complexity of the backend. Not complexity in terms of business logic. This is all pretty simple, isn't it? But it still adds complexity because you have to go back and keep changing things in two places, in your backend and the front end. Now, we haven't even talked about admin UIs yet, because you're selling software to other businesses. You need to have them a way to like manage their orders, see how much money they've made, things like that. And as you can imagine, by the time you're selling to businesses, the complexity just keeps on increasing on your backend. So what was the connecting thread between all of the various screens that we saw right now and the story that I was just sharing? It's all CRUD APIs. As I was saying, the complexity, I mean, there's no complexity there. It's not like we are running ChatGPT in the backend, or it's not even like we are doing stable diffusion or something. It was just simple like push and get operations. So what are the potential solutions for this in 2020? You could go with hosted platforms like Supabase, Firebase, or anything else. The cons of that are like you're writing a lot of custom code. So what these platforms basically allow you to do is like access your database in your front end, which is exactly what we are trying to do. But it's still not exactly transferable. If you decided to change platforms at any day, you're still like kind of locked in because of the custom code you're writing. So it's not exactly ideal. There's serverless functions. I think serverless functions sort of have had their day now because everyone's sort of moving into other things at the moment. Serverless functions still run on the server. You have Next.js, who is doing it the right way, I would say. There's Netlify, which still does some custom things around their serverless functions, but everything in the end runs mostly on like Lambda functions. We all know about that. What are the cons of that again? There's vendor lock-in. You're locked into whatever vendor you're working with. And let's be honest, you're still writing APIs, and that's exactly what we are trying to avoid. So what was the solution to this? My solution and the solution this solution was built in collaboration with a lot of people. It was basically Rocket RPC. So my name is Akash Joshi. I'm a software engineer at Meta. And today I'm going to talk about how we can destroy the client server barriers with TypeScript. So I think I've talked enough about what this does and what it's about. Let me show it in action. So I'm just going to jump directly into the code right now and show you what the server looks like at Rocket RPC. So this is the server. It's 19 lines of code, and it doesn't really get any more complex than this. How you use Rocket RPC is by first importing the server from the library. So this is currently importing from my local source. You would import from Rocket RPC instead, of course. This is the complete API object. And inside of the API object, you basically write all of the methods that you want to access on the front end. And this can get more complex as well. And I'm going to get into that in a second. You export the type from your original object. That's how a lot of TypeScript-based RPC frameworks also do that for type inference, because that's the sort of the easiest way. And then you just pass in a port number or any HTTP relevant object. So if you are using any HTTP framework like Express, Fastify, or anything else, you can reuse the same object here and host Rocket RPC on the same server. And then you pass in your API object, which was literally like these few lines of code on any other methods that you want to import in here. And then you just pass in your server options. For example, right now my front end is hosted on a different port number, so I'm just opening it up to everything right now. And now, yeah, let me get into the front end. So for the front end, I have a simple application in front of you all right now. This is an app which is sort of integrated into the Rocket RPC server at the moment to get the data that you see at the top. And then at the bottom, it's like a simple like to-dos app. You add some data in here, and then it creates a bunch of to-dos, and then you can change the status of it to done or not, and then remove it from the screen, stuff like that. It's pretty box standard. Yeah, and then what we are going to do right now, or try to do at least, is to add persistence to this by calling Prisma from the front end. So this will be fun. Right now, let me explain the client code a little bit as well. It's from here to here. So from line number 2 to line number 12 is where you should be looking at. At line number 2, I'm importing the client from the client. I was having issues in Vite for doing like these automagical imports where you sort of destructure your object from the source. So I had to import it directly. We import the types again because we need type inference on the front end. And here I'm declaring the client, which is again declared in one line. I'm initializing the client, passing in the types from the server, passing in which port I should connect to. So in this case, it's pretty straightforward, localhost 8080. And then what it returns is all of the methods that I had passed in on the backend. So this ping that I've passed in, the sum, I can destructure all of this on the front end, and all of this with type completion even. So what we are doing here is calling the ping method. The ping method takes an argument and returns a string like pong, and then whatever argument you are passing in. And yeah, we are calling the ping method here, setting it to the ping response variable, state variable, and then displaying it there. And that's exactly what we are seeing here. If I replace world with anything else, I mean, as you might expect, it just hello Svelte, I would say. And yeah, it will just replace it with whatever I pass in instead. So yeah, I mean, that was the pretty straightforward part. Now we'll get into the interesting bit. So I'll expose the Prisma client from here now. Yeah, this is always the most interesting bit, trying to make it figure out where the Prisma server is. So at Prisma/client. Yep, that should work now, I think. Yeah, and now I can access Prisma on the front end. That's great. So I'm going to use this to add persistence to this layer, as I was saying. So we need to save our to-dos to the DB and also return them from the DB whenever we refresh. I won't get too into the depths of it, but at least show you how it might work. So to store this list of to-dos at the moment in the front end, I'm using a variable called to-do list. And this to-do list is typed with to-do, which is currently a custom type that I've created. Instead, let's type this with the actual Prisma type. So let me go into my Prisma server at the moment. The schema is visible on the screen right now. So yeah, this is sort of like the standard to-do schema that I've created. The only two fields that we should be interested in at the moment is the status field, which is the Boolean, whether it's done or not, and the text field, which is like what is actually stored in that to-do list, to-do string. So yeah, right now I just import this from Prisma, from the actual Prisma client instead. So this gets all of the types of, yeah, the Prisma schema basically. And what we are trying to do next is set the initial value to whatever we can get from Prisma. So I will do prisma.todo.find many. And then this, of course, returns a promise. So I add a .then at the end, and then set that value to to-do list. So I will do something like new or like stored to-dos probably. As you all know, naming variables is the most difficult problem in programming. So yeah, I'll set this to stored to-dos. Of course, it won't do anything right now because we don't really have anything in our DB. But as you can see, it's starting to make calls to the backend at the moment. And okay, even though the, okay, yeah, it's not logging anything because there's nothing there to log. What I'm going to do next is replace the add to list function. As you can see, it's an on submit function which prevents reloads on submit and then sets the to-do list to whatever the new list item we added is. So instead, I'm just going to do prisma.todo.create, and then it expects some data, which is basically like whatever text I'm submitting at the moment. And wait, just a sec. Yeah, I need to add a value to it. So that should be, I guess, new. Yeah, let me just check what's binded on input at the moment. Yeah, it's new item. So I just drop in new item inside. And then this creates a new Prisma object. And then whatever object that this creates, so new to do, I set that on my list here. So I just bring that back up and then replace this with the new to do instead. And yeah, that should stop complaining now. And if we go back here and if I add a few nodes, so new to do, then yeah, I'll just keep adding stuff. This is actually happening in real time. Yeah, thank you. And yeah, if I refresh my page right now, this is all like fresh data you're getting from your Prisma DB. This is all stored in your database. So yeah, let me get back into the slides again. So that was the exact problem I was trying to solve. I was like bored of writing APIs all of the time, and I wanted to just expose my ORM on the front end. There's some security stuff on top of this. Don't worry, hackers won't be able to access your whole DB, but we'll talk about that later. So yeah, just wanted to create that basically and solve how to create apps fast. And it doesn't just work in contexts where you expect the front end to be a browser or like the client to be a browser. This can work for inter-process communication as well. So imagine that you're writing GraphQL resolvers and your data is stored on a Prisma DB somewhere. You don't know where, but like it's there out there somewhere. So you expose that data via Rocket RPC, of course, and then you can call that, call the Prisma here. The GraphQL resolver doesn't need to know what the DB secrets are. As you can see, we aren't really passing in any secrets. It's like the server URL or something else, and then maybe you use an authentication token to authenticate yourself to the server. But other than that, the client doesn't need to know what the secrets of your Prisma DB are. It's not limited to Prisma either. You can use something like SQLize, for example. So you could use, you could connect SQLize to your SQLite data in your memory, initialize a user class, and then expose a get users method, which returns all of the users that you have. And then now you could have like data from two sources. So you could use data from your SQLize and data from your Prisma in the same application. And another problem with Prisma at the moment is that you cannot have multiple clients. So you're limited to sort of one client at the moment, and this solves that problem as well. So you could have multiple Prisma clients imported from different servers, and then you can call all of them natively on the front end. So yeah, that was sort of what I was going for there. And why is there an empty slide? Okay, yeah. So I hope by now this is what your expression is, and I hope your mind was blown by looking at this cool example. And you might ask, how does all of this actually work? And yeah, now I'll get into the depths of my library, because I want to show how all of this technology works as well. Don't be scared. It's like less than 200 lines of code, and it's pretty simple. The first thing that it works on is object proxies. So I was talking with Dan, who used to be an engineer with Prisma recently, and we had a discussion around object proxies as well. And did you know that the Prisma client also uses object proxies? So object proxies are a really like underused thing in JavaScript at the moment, and I think there's a lot of cool stuff that we can build with them. Let me go into the source code of my library for a second here. So if I go into the client here, I can hide that now. I don't really need that. So let's have a look at what an object proxy actually does. So the object proxy that I'm using to handle all of the API calls and everything that happens on the front end side is called client proxy. I'm creating a proxy here which has get and apply, and that is all I need. Get is basically whenever you're trying to access a property on the front end. So if we go back to our example where we were sort of doing like prisma.todo.find many. So whenever someone tries to access todo, they're actually accessing the get property on the proxy. And we are sort of building the path on the front end of what method the user is trying to access. I generate the complete method on the front end by every like dot operator that the user accesses. And then apply is called at the end. Apply is sort of similar to how function.apply works. You basically call a function, and then I generate this complete path. And I use this complete path, send it to the backend, and then based on some socket.io magic, it fetches the response from the backend. I'll go into the details of that as well. So the next up, it's socket.io, which is on the network layer. Why socket.io? It's because I didn't want to care about the network layer. This library isn't supposed to be about the network layer. It's supposed to get out of your way and let you do your job. And socket.io is like one of the fastest WebSocket layer, which is also reliable out there, because socket.io downgrades to HTTP long polling if your system doesn't support socket.io. And the way I'm using socket.io is pretty straightforward as well. I'm just connecting to a socket.io server on the backend, and then I'm emitting the function call here with all of the params, which are basically like what arguments am I passing in, what path do I want to call on the server, and then whenever the backend responds with whatever the result is, then I just resolve the promise that I have on the front end and return that data to the user. And lastly, after socket.io, we have TypeScript, of course. And TypeScript is actually what makes all of this work and what is bringing us all of these cool frameworks like TRPC and RocketRPC as well. So how am I using TypeScript here? Basically, I'm passing a generic to my front end, and this generic then sort of I'm wrapping like a promisify record sort of type around it, which promisifys all of the return types, because all of the return types on the front end need to be promises, because everything's traversing over the network layer. So it's basically this one type which is sort of doing all of the magic that we see around TypeScript here. And yeah, that's pretty much my talk, I guess. Thanks for watching so far. Yeah. I'm.
Thanks, Akash. Do you have time for any Q&A?
Yeah. So I'm looking for contributors at the moment and also users, of course. So you can go to rocketrpc.com to try it out. I'm also at the Writing Dev on Twitter, so you can reach out to me in case you have any questions. And yeah, I'm up for Q&A right now.
So there was 2 questions from the chat on YouTube. So one was, is this code available on GitHub?
Yeah, that's the website. I mean, it redirects to GitHub right now. So, yeah.
Okay, so there was another question, which was, why should we use TRPC when we can use Svelte form actions instead?
I'm not aware of SvelteKit form actions, unfortunately. I guess form actions are sort of like when you submit the form and it just runs some method on the backend instead.
Yes. Yeah.
Yeah, I guess, I mean, depending on your use case, you could go with that, of course. I guess the camera's there, so I should probably speak there.
That's okay, cool. Does anyone here have a question? Or Julia?
I was just interested in...
Julia, just let me grab the mic. Sorry, hang on. Also, everyone, we've got bonus talk coming up from Julia as well. He's going to ask this question now.
I was just interested in the security aspects, which you sort of, because it's sort of like, I mean, I can see that it's sort of it's wrapped, but I'm sort of thinking, how do you prevent people from just interrogating on databases in ways that you don't expect, or
yeah. So
in response, or it might be returning data that the front end isn't actually needed, but that might have sort of more privacy. So there's a
yeah. So basically, I guess the first answer is sort of that the developer is still in control of which data they want to be accessible on the front end. So as you can see here, I have other methods here as well. So instead of returning the whole Prisma client, I can just create methods like return to-dos or something right here, and then call the Prisma client here, and then return the data from there. And it still gets all of the benefits. So I guess like I could do something like get to-dos, and then it does all of the type completion automatically, basically. So I could do something like, yeah, I need to move this to the top now. Let's say const Prisma is equal to this thing, and then we remove that from here, and then just, yeah, Prisma.todo.find menu or something. So at this point, it's sort of working like GraphQL resolvers now, I guess, where you're sort of defining methods with type completion, and TypeScript help to like return data from the backend. The other thing that I'm going to work on or start working on and need contributors for as well is like allow listing. So only allow certain methods on the front end to access the backend, and these can be defined by like methods which were defined at dev time. So whenever someone runs npm run build, only those methods are allowed on production, and the rest are sort of 404 or blocked off, I guess. So that's my answer for that.
Sorry, let's get Julian set up for a talk. Anyone else have any other questions? Here we go.
Might be a silly question, but you cannot do this with TRPC?
You can't expose your complete object with TRPC. Of course, both libraries have different ergonomics with how you work with them. In TRPC, I guess the ergonomics that they are going with in the developer side is sort of working how it works with GraphQL, I guess. But what I'm going with at the moment is that I'm trying to go with how function calls work in JavaScript. That's sort of the ergonomics that I'm aiming for. The developer shouldn't even realize that they're making a network call.
No one else? Oh, okay.
Right. So I just want to check on sort of, especially because here it's Svelte Society and Svelte does that specifically really well on sort of getting your server data type, etc., everything pre-generated for your content without exposing anything as a data. For example, you can have your Prisma, but basically you're having you take anything too. You have your Prisma client behind your server, yet all of your typing is access to your client. So then in that sense, why should we use this?
I mean, again, like, I guess I sort of answered this question already about like how I'm trying to bring the ergonomics of like making native API, like native method calls on the front end, which actually execute on the back end. So this doesn't necessarily need to be Prisma. It could be like computing very large numbers on your GPU or something else. So you could have an example. You could, I don't know, define a method here which actually runs via a GPU connector to on your GPU and then returns the data from there, for example. So yeah, it's not exactly limited to Prisma or any library that you can think of.
Awesome. Thank you, Akash, and thank you everyone else for your questions. As I just mentioned, we've got a little bonus talk from Julian Burgess. He's going to talk about. Thank you. Just get to the screen. It's all right. Don't worry about it. Take the mic off. It's fine.
Yeah, the mic's off right now.
Don't worry. Right, let's just get Julian set up.
Good questions.
Yeah, do you want to share your screen as well, Julian? Yeah. So, right, where's your camera?
It's not because it's
That's
not,
fine.
is it?
I don't think so. So that's fine. So present.
I'll share screen.
There we go.
Just select the others on the screen.
Okay, so looks like we've got a let Firefox monitor the screen for Julian. While he's doing that, I'm guessing it's going to have to restart. I'm guessing you're going to have to restart Firefox as So you shared it. Let's go back to StreamYard again. So is that your screen now? So you're sharing your screen. Okay, cool.
Yeah.
Right. Brilliant. Okay, so it looks like we're good on the stream. Where's your, just move, bit of screenception, everyone, you're welcome. Let's just change this over to this one. And there we go. Right. And back there, I guess. Right. Got a clicker?
I'll probably just stand in.
All right. Cool.
Okay.
All right. Brilliant.
It was-
Thanks for your patience, everyone. So get ready to start now.
Cool. Okay, don't worry about the menu at the top. Hello, I'm Julian. This is, I can't see my notes, but hopefully I'll just remember them. This is just a talk I dreamt up quickly because Scott had asked me about doing a talk and I was like, let me think about it. And then the pressure was on, so I just did this earlier today. And it's a bit of a kind of like trial. It's quite a beginner thing, hopefully, but a bit of a trial as to whether this makes any sense and whether it might be useful as a longer talk. So what does immutability mean? Generally, it just means that you have some kind of object which you don't mutate, which means sort of not changing it. Because very often you, well, I shall get more into that. So, you know, you're sort of always changing things in computers, so about how you're sort of changing things. So you're sort of taking, then the object stays the same, and if you want to change something, you make a new copy of it with the change. So that's what the talk is about. So Svelte components have an immutability option, which it may be, so hands up, who's familiar with this? Oh, now this is interesting because I wasn't sure. I was like worried that everyone was going to be like, oh yeah, I know this, boring. So yeah, it's interesting because it's been in there a long time as well. I think it was in maybe even in version 1. I don't know, but it's been in Svelte for quite a while, and it doesn't particularly jump out. It's one of those things you can just sort of go through and not really notice it and think, oh, I don't know, why does that matter? Who cares? So there's a link there to the docs. So yeah, that's all you do. You just add the Svelte options immutability equals true. So in the docs, it says that what this does is it changes the way the compilation works so that it just uses simple checks to see if the object has changed, which sort of maybe describes what it's going to do. It's not necessarily always obvious as to what effects this is going to have. And there is an example. So I have, so why should you care about it? It can have really quite big performance effects. And Svelte is all about doing less work. And this is where it can really help with this. So here is the demo. Whoop. Hopefully, God damn, right. Okay, right. So I've made these REPLs. They're not very exciting, but I could share the URLs later. Let me make them a bit bigger. Okay, so so here we have the default component, and I've just added the tag here. And basically, if you take it out, you see all that really happens is it goes from safe not equals to just not equal. And so it's really quite a small change. I mean, there might actually be more going on. I'm not, if anyone who's a contributor might be saying, oh yeah, but once you kind of get into it, it does all kinds of changes. Not sure, but superficially at least, it's sort of seeing something which is fairly simple. And so here are some very simple examples. So I've stolen some of this code from the example and kind of made it a bit fancier. So the first object we have is just, it's slightly the wrong way around. Okay, it's just a simple value. So this is a plain value. You can ignore most of this code. There's just value equals random number. And when I click this, these buttons are just showing the code that it runs. So this just chooses a random number. And we see that every time it updates, we see it flash. So obviously, even if the number is the same, it still also renders because, why does it? It shouldn't do, should it? Well, I don't know, it does. Let me not think about that too much. So so this is where we're just mutating a value. So because a value kind of is always is immutable. So it's kind of, we're doing it by assignment. So we're saying value is equal to this number, and we're assigning a new number. And when we use plus equals, that's still assignment. And I was kind of interested as to whether would plus plus make it still change or not. What do you think? Hands up if you think it's going to change. Yeah? It does. So yeah, plus plus is also, Svelte knows how to deal with that. So then the next one is a simple object. So the first one was a value. This one is an object. So we're saying the original object here has a name, which is Peach. I take a copy of that object. And then when you click these buttons, I return a random fruit instead. So this is where I'm mutating the object and nothing happens. Yeah, so we're assigning it to a new fruit, but we don't see any update because of this. So if this wasn't here, if we took this out, I hadn't thought about doing that earlier, that was quite nice of doing it. So now when I mutate it, it changes. So it's the same code is executing, but Svelte is ignoring it because we've said it's immutable. So I mutate the object, nothing happens. If I replace the object with a different object, then it happens. And so that's the kind of key bit. And I feel like it's one of these things, it is a fairly simple concept, but I feel the examples and the documentation just kind of skip over it quite quickly and you can miss it. So this is basically the example slightly enhanced. And so here we have the same object, the same component, and one has immutable and one doesn't. And so they're both rendered here, both connected to the same list. And so when I tick and untick these items, what you notice is that for the mutable one, every single one of them is being re-rendered. But in the mutable, only the one you change gets rendered. And so that's where you can have huge performance benefits potentially if you have quite expensive rendering code. And I think that's it. Yes, that's just a link to the docs. Thank you. So yeah, I don't know. I hope that was helpful to people. I'm glad that not everybody was like, oh, I've heard that boring. So I don't know if that was interesting. I was thinking I could extend it a bit more, have some sort of more real life code where this can be applied, and perhaps even kind of like, look at this enormous speed up we've had. And also partly as well about any sort of tips and tricks, because also, that's obviously very simple where you've just got to do, but you're kind of like how you're actually removing and adding your kind of mutated objects. You're kind of you're no longer mutating them, so you have to throw them away and get them back into a data structure. So I don't know. That seems like maybe as possible. Yes, I could expand on that.
I think it's great, and I have a beautiful thought. So I'll allow there. Does anyone have any questions here for Julian? And quickly, could we just give Julian a bit more appreciation for coming up with this story? So I love Julian speaking. He spoke at the meetup in July, I think, and then they went over to Svelte Summit, and that was a really good talk. So thank you very much, and also thank you to Giorgio and Akash as well for the talks. So one thing I'd like to know is, how did you do the rendering for each checkbox there?
That's actually, I stole that from the example, and it has, there's a flash thing here. So the example's made it extra fancy as well, because they've bound the div to it, and then they're just calling flash on the div. But it basically, it applies this style to it, and then immediately removes the style, but it has a transition.
Nice. And this is in the documentation?
Yeah, this is, I mean, actually, cool. This is the thing, it's exactly...
So this is what you get on the documentation.
In fact, I could...
tutorials.
It's right down here at the very, very bottom, weirdly. Oh. And the other thing, it's got 2 errors on it, so it's a bit out of date, but also, I find with just having 3 items, you can kind of miss that it's like, you're rendering just 1 versus 3. That was why I was kind of like, I feel like they just need to add like 5 items or something. It's a bit more apparent. And I think also because you remove and add the emoji as well, your eye notices the jump in and out more than the flash.
Cool. Any questions from anyone? Akash.
So what Svelte is doing internally here, is it similar to what UseMemo does for React?
I don't know. I don't know about React at all. I'm pure. I did have though here on the front page. No, I've lost it somewhere. But I mean, you can see. Would this work? So it's really just the difference between safe not equals is doing this, and not equals is doing that. And somehow that has big cascading effects. It's kind of essentially just sort of saying, if this is the same object. So, because I mean, the idea is that, Svelte is pessimistic, because they sort of say, I don't know if they still have that word in the documentation because it sounds a bit sad, but it's pessimistic, and so it assumes that people might be doing things like this by default. But yeah, if you can avoid doing it, it seems like there's certainly the potential. You can see how this could potentially improve a lot of apps for their speed, but it does require that slight being more careful about how you're modeling your data.
All right, thank you.
Thanks.
Cool. So I'm not sure if I actually mentioned that Julian works at...
No, shh.
So,
this isn't an authorized talk.
Okay.
Yeah.
Sorry about that. Julian works
somewhere. Yeah.
Data visualization.
Oh yeah, do data viz. Yeah.
If anyone needs to know.
Yeah, that's particularly like that, where we might be, say you're rendering a map and you've got hundreds of like bits of an SVG, but you're only sort of rarely changing more than a handful at a time. Then this is something which particularly speeds things up.
Yeah. That's very
Yeah.
So I've got a question here.
So this is what I encouragement for the actual talk that you're thinking about. I would like to also hear about cultures with this and like where you might trip over using this in
Yes. That's particularly what I was thinking with like how to, because it's very easy when you've just got a to-do list and you're just like, okay, so I'm just sort of like taking these things in and out. But yeah, how to actually manage, because you're going to have collections of objects and you need to be able to make sure that you don't accidentally keep references to the old object around. Yeah. So I don't know, I haven't thought about that. That might be where I get to use weak maps or something like that, which is also another exciting thing to look at.
Any other questions? So I'd also like to apologise as well because there wasn't Q&A for Georgia. Georgia, come on quite quickly. If anyone has any Q&As for Georgia about microphones, you can ask him now. If not, we can wrap up. Oh my gosh. Okay.
Thanks.
Thank you, Julian.
Thank you.
So George, I think about like developer economics and how different libraries were recently across my ongoing thing. Just wanted to ask, like, have you used any existing like favorite solutions for microfrontends? Like for example, Astro is something which is quite popular or seems to be popular.
Recently, I used Quick with micro frontends, but without any kind of library, because with Quick you can do it quite straightforward. It's just HTML and CSS. So I have in my repo a project with micro frontends, and it's called Quick Dream Demo. So I used Quick. Astro I never used, so can be interesting to use it for some use cases. Yeah.
Yeah, I'd love to see a comparison for that. Thank you.
Thanks.
Cool. Anyone else? And again, apologies, Georgia.
Yeah. I can say that in my repo you can find a lot of use cases and POC with Svelte, React, and Vue. So have a look.
Okay, I think that's it. You all done? Brilliant. Okay. Thanks everyone, and thanks everyone online for very much as well.
Thanks.
Yeah, thanks, Julian.
No, you're welcome.